Welcome back to Simulation and Prototyping. This is part 2 of 3 for a simple little project where we're going to take a random kind of three-dimensional star object, drop it on a plane, and allow a site to kind of inflate around it. So with stage 2 for this tutorial, stage 1 was the creation of this little wonky kind of star object with different legs and arms. We can modify it given a number of random parameters through one seed value. So now we have this. So let's start the second part, which is going to use Kangaroo 2. And we need to define a plane to drop this on. So in Rhino, I'm going to go to the top view. I'm going to go to surface, plane, corner to corner. I'm just going to draw a plane that's large enough so that if this thing bounces around a little bit, it will still be on the plane. If we go back to our perspective view, we can see that either we could move our object up. We could move that point that we created. We could give it a Z value. So this is up. But the easiest thing to do now is to just move our plane down. And I want to set the plane to be roughly, I don't know, two to three times the height of our object. So we can see what that looks like. Let's create a brep container for our plane. So we can set one brep, we'll select the plane, and now we can hide that object within Rhino. And now we have our two objects. We have our brep and we have our plane. So to use Kangaroo, we typically build a few different elements and all of those things plug in. So we can start in a pretty common way is that we have a merge object. This gets flattened down. This will plug into our bouncy solver. Here's our bouncy solver. Those merge objects will be our goal objects. We want to have our iterations. I've tended to use 50 for this in the past. I'll set this with a small panel. We want to have a Boolean toggle so that we can turn this on or off. It is computationally intensive, so we want to be able to have this off when we don't want it. And we are going to want a button for our ability to reset this. So that should be all of the main components that are going to plug into the Kangaroo bouncy solver. So let's look at how we connect these and how we bring them across. So the first thing that we're going to want to do is take our brep join, and we're going to make a mesh brep. We're going to do this with both of our objects, and we'll do it separately. So let's copy these. And let's see. So let's plug in our brep into our brep. We get that mesh. We can hide the brep container. We'll plug our brep into our mesh here. We can hide that brep. And what we also want to do as this comes out, we saw that that was 6 closed breps earlier. This now created 6 meshes. And so let's do a mesh union. To turn this into one mesh. And so now we see the result is one mesh. And that's good. Let's use that to do a couple of things. I'll make a little more room here. So with our main under Kangaroo 2, we want a show. This show We want to show our object. So we can hide that first mesh. And we can plug that show into our merge. We want to create a couple of rigid bodies. And these are located on the far left tab. And it looks like a spinning top. And so we're going to have two rigid bodies. So we can copy these. The first is going to be our plane. We'll plug that into part. And the rigid body will come out and plug into our merge. Doesn't look like those are lining up, so we'll see if that's a problem in a minute. But our union mesh is also going to be a rigid body. We'll plug that into part. We'll pull the rigid body out and plug that into the merge. We have our show. And then we need two more things. We have to add a load, and then we have to do one other element, which is the solid plane collide. So under goals for point, let's use load. And what's nice about this is we're going to use a single point, which is going to be the volume of our unioned mesh, which will be the centroid. There's the centroid point. This will plug in to our merge, and then we just have to give it the force vector. So the force vector is going to be z. And we actually don't need a lot of weight with this, but we also need it to be a negative number. So I'm going to create a panel, and I'm going to set it to be 0 minus 0.05. And we'll see what makes sense for what you're doing. And as we know, as we've experimented with Kangaroo previously, a lot of these values are relative to one another. So as we increase one, we may need to decrease something else. So I'm going to hide, let's see if I can hide any of these things yet. I think because we've got them coming into the bouncy solver, we can hide most everything. So the last element that we need for this to work is to go over to the goals and the solid plane collide. So we'll add this. Our solid is going to be our union B-rep. Our collision plane is going to come from our B-rep all the way over here on the side. And I believe I've experimented with both, and it doesn't want a mesh in this case, but it does want our B-rep. So that's going to be our collision plane. And I don't think I even need to set the strength for anything. So let's plug this into the merge. I believe that all looks good. Let's toggle our Boolean toggle. And now, at least for me, it's working. Hopefully it's working for you. And what it should do is find 3 points that it sits on. And so let's see. Okay, in terms of representation, what I was going to do is hide some of these things. I think we can hide all of these things. And what we're seeing is the bouncy solver. So let's pull out our geometry from this, which is from the output. And so let's create a geometry container from our outputs. Now we can hide our bouncy solver. We just end up with that. And what I want to do is to play with the representation a little bit. And because with this geometry, if I create a panel, what we have are usually a few different things. We can see we have our starting mesh, our ending mesh, and our planar mesh, and then 2 nulls. So first thing, I'm going to keep the panel here. Let's clean our tree because those nulls can create some problems for us. So let's just plug this into our tree. Let's look at this now. So now we've removed the two nulls. I believe we can hide our geometry, right? And our clean tree is represented here. And now let's pull out just basically all we want is the object as it's sitting on the plane. And so we'll do that with list item. And our list is going to be our tree. I believe the index, let's see if we hide this. So it looks like index 0 is, I'm going to copy my panel from over here. Plug this into index. I'm going to turn the wrap to false, which will give us an error. But now if we set this to 0, 0 is the plane. If we set this to 1, that's our object at the top. And if we set this to 2, that should be our object sitting on the plane. So the reason why I did that is now that allows us a little bit more freedom to set a few of these other things. So we can even turn back on our first brep. We can see the starting condition. And now we can also use custom rendering or custom previews for each of these. And so let's set our geometry for this object down here. Use a swatch. All right, so now our object that we have sitting on the plane is lime green. We could copy that custom preview all the way over here to our brep. Plug that in. The reason why I'm not using the same one is that with the color swatch, what I want to do is turn it and make it kind of transparent. And I'll do that with the alpha channel. So now that that's set, we can hide the brep. And now we end up with the kind of initial condition and the condition on the plane. So let's take a look at that. Let's just change up our, so the other thing that I like to do is to be able to control some of these things. So let's set this to false for a second. I'm going to pull both the button and the toggle all the way over to where the seed value is. And maybe eventually pull these all the way over to the left so that when I come back later, I know that the elements that I want to manipulate are the elements that are kind of all together, usually at the left. So let's change the seed value. We can turn on true, and we can reset it. So now each object, as we randomize it, as we change the seed value, we just need to reset and let it drop. And remember, 3 points determine a plane, and this is why tripods have 3 legs. And so what it's doing is it's using that centroid, using the force that's coming with it to find 3 points that allow it to be stable. And so I think this is a kind of fun thing to do. I do like working with the rigid bodies and seeing how these things work. And then it does find a kind of balance. So this concludes part 2 of our 3-part tutorial. And so what we can do is to pull all of these things together. So let's see, this is visualization for that. Here's our geometry that's there. Everything that we've just created here is our simulation. And I'm going to pull the visualization part down too. so that I know those are kind of broken out, so I can always manipulate them later. So I'm going to join all of this together, or group all of it together. So then that is our first kangaroo simulation. We just have to remember that our control for that is all the way over here. I'm going to turn that to false as we begin our next, the third and final part of our tutorial, which is to allow the plane to be inflated around it, to give it a kind of pillow effect. So now is a nice stopping point. If you want to take a quick break and then come back and join us, we're basically going to do something similar. We're going to take this block in terms of a kangaroo simulation, swap out the solid body components, and we're going to inflate it. So take a quick break and come back.